Hello everybody, today we are going to be going over example 9, suspension system 1 using Adams 2024. To begin, we're going to want to click new model and then change the model name to whatever you desire, but I'm going to be calling it suspension. And then keep the gravity to earth normal, the dash global Y, the units the same, and then select the working directory for your application. So click OK. Once that's done, we are going to import the file. So go to File, Import, and then for File to Read, we're going to double click that to open the file for this program to go over the suspension system. And for this, it's going to be called suspension_parts_start.cmd. So wherever that's located in your downloads or gallery, just go ahead and upload that to here, open that, and then click OK. And then once the file's opened, it will show all these geometries that are kind of hidden of the main suspension setup. But what we're going to be doing here is we're going to shade the overall suspension by right-clicking the screen and clicking shaded, which will give good visuals of the whole, of all the parts themselves. So to begin, we are going to select the connectors tab, then we're going to create a spherical joint. So with this, we're going to have two locations, two bodies, one location, normal to grid, and then pick body for 1 and 2, which our first body will be the spindle wheel right in the center. So go ahead and click that. Our second body will be the tie rod, which is the yellow one right next to it. And then we're going to pick a location for the ground, which will be right between them, which is ground.hp8. So once you click that, you'll be good there. Now we're going to create a hook joint, which is in the same category there. It's just bottom left of it a little ways, right in the middle left. So create a hook joint, click that. For this, we are going to keep the two bodies, one location the same, pick geometry feature, and then both the pick bodies the same. So that will be the same exact thing there. So then for this, we're going to click that tie rod again. Click that tie rod, and then once you click the tie rod, we're going to click the steering rack. Once you're done with the steering rack, we're going to set the ground again, which is right between those, and this will be ground.hp7. So go ahead and click that. And then this is where we're going to be creating the vectors. So from this ground, we're going to go across the tie rod and select HP8 right there. And then for our second vector, we're going to go to HP13, which is across that steering rack right there. So select that. And then now we are going to create a point motion, which is going to be under the motions tab. And under general motions, it'll be the one on the top. So you're going to create or click point motion. So click that. For this, we're going to do select one body, select one location, bodies implied, and then keep the others as standard there. And then now we are going to select the spindle wheel center, which is kind of hard to get, but it's right there. Select that. Now we're going to select the center Y, which is going to be next to that as well. I can get my mouse on it right there. And then that will be the vector for that spindle or that wheel center. And then now we're going to modify the motion. So what we're going to do is right click and then go to the motion 1, click modify. And then for this, we are going to create a function. So under function time, you're going to click the 3 dots. And then we're going to get rid of all the command numbers in there. And we are going to create our own command, which will be 80 times. Then you can scroll down on this list for any trigonometry symbols or anything like that. And use this. We're going to use the sign for this application, 360 D for degrees. Oops, and then times time. So now that we have that function plugged in, we are going to click verify to see if it is the correct syntax or not. So since the function syntax is correct, then that means we know that this is good. So click OK, and then click OK again. Then we'll be good there. And then click OK on the point motion. And then now we're going to modify the translational joint to be a fixed joint. So right click on the joint rock body, which will be all the way out here. So you're going to be clicking on this or modifying this joint. Click modify. And then for this, we are going to change translational to fixed, which should be at the very top. And then after that, you're going to click OK. And then to verify and simulate the model, we are going to click on the simulation tab. So once you click on the simulation tab, we are going to simulate or run a simulated script, which will be right here. And then after that, we are going to click on the interactive button right down here. So click that. And then now we are going to change the end time to 10. So instead of 2, we're going to change that to 10. Then we can change the number of steps to 500 instead of 50. And then we're going to click on the green button to watch the suspension simulate. So there it is, simulating up and down in that function that we gave it over an interval of 10 seconds. And then we can, I'll move this over here again and run the simulation again. So yeah, that is the example 9 of the suspension system number 1, part 1 completed, and we will now be moving on to the suspension system part 2. Thank you.